How's it going, everybody? In this video, we're going to continue the ACL variation of the setup and look at the configuration to deploying ACLs through the concept of localized policies and applying those to templates. Because unlike the vEdges where you go on the CLI, you actually have to go through and push the localized policy down, just like we did with vEdge2 for the BGP policy. It's got to get applied and then pushed, and then you can manipulate it. Now, since we're going to be doing this through vManage, we're going to be taking a look at affecting traffic on the same interface in two different directions. So we have traffic that is going away from the vEdge, so coming from the router to the vEdge, and the traffic we have going to the router. So just to make this easier to follow, what I will be doing basically in a nutshell is I'll be creating a ACL that calls the local loopback of each site right here. I'll be calling that local loopback, and I will be denying it from having internet access. So basically, if you're sourcing any traffic off of 13.13.13.13 or 15.15.15.15, you will not be able to get to the interface, to the internet, and I'm going to apply that inbound. Okay. Any other traffic will be permitted out of the gate and will be good to go. Now I'm also going to create an outbound ACL on that same interface, which is gig 0/2 on both devices, and that's going to say that if you're going to iOS 13 loopback, just put it in here, loopback 0, you're not going to be able to reach it via telnet. The same thing for for vEdge4 for router 15. We're going to say if you're trying to reach iOS 15 via the loopback 0, you're not going to be able to reach it via telnet. And actually, let me back that up just a little bit. We won't actually be able to do it based off the loopback. What we will do is, if you're trying to reach iOS 13 via telnet, you won't be able to. Same thing down here. If you're trying to reach router 15 via telnet, we're going to apply this in the outbound direction and go from there. So with that being said, let's go ahead and set this up. Now, one thing I do want to mention before we do this is I have tested this out in the past, and in order for this to work in both the inbound and the outbound direction, what we need to do is create both access lists and call them from the same policy that we're going to push down to the vEdge. So once you've created a policy, and now this might be updated in newer versions of code. So I'm dealing with 18.4. I will take a look at some of the release notes for whatever version I upgrade to, because we will be doing an upgrade at some point in the future. But for right now, the only way that it's able to get pushed on 18.4 is if you go through and you combine multiple access lists to the same single policy and then push that policy from vManage down to the vEdges. Once we do that, then we'll be in really good shape. And then we can go to the individual interfaces of the templates specifically, and then we can push the ACL name to the interface. So the way that the flow logic is going to work is that on the vManage, we're going to create the list to match on the traffic. So we're going to create lists to match on the loopback addresses of the devices. And then we're going to call those specific ACLs, or those specific addresses from an ACL for each individual device, one for router 13, one for router 15. We're going to push those specific ACLs down to the vEdges, and we're going to apply that stuff inbound. So as traffic comes from either router 13 or router 15 inbound to the vEdges, traffic will get blocked if it's being sourced from either one of their loopbacks. That's one specific configuration that we're going to have to do. In order to block telnet outbound from any other devices to the routers, what we're going to have to go through and do is create another access list, and what we'll do is we'll match on just telnet as it is and not necessarily a source or destination. We could be more specific, but we're going to keep it pretty generic, where we're going to just match on TCP port 23 for telnet, and we're going to, once that access list is also created, then we're going to call the ACLs that are going to block the traffic from the loopback addresses of the individual devices inbound, and we're also going to call the ACL that's going to block telnet outbound towards the routers. And And when we do that, one ACL, the ACL that matches on the loopback addresses, is going to be matched inbound. So traffic coming from the router to the edge will be blocked if it's being sourced from the loopbacks. If we're sending traffic from another location to one of the routers that sit behind VH 3 or 4, that traffic will get blocked, specifically if it's telnet. And we're going to set that in the outbound direction from the V edge out to the router. And that's going to be basically what we are going to accomplish in this video. So let's go ahead and dive into it. I have to set this up from scratch, and I'm going to go ahead and get this knocked out real quick. Let me go ahead and move this over here just a little bit so we can see VH 3 and 4. So I'm going to first come in here and go to policies, and I'm going to click on localized policy. Okay, so right now I don't have anything created. I'm going to go ahead and create a policy, and the first thing I have to do is call a data prefix. So as you can see, I have a couple data prefixes. Let me go ahead and just delete one of these so you guys can see how this gets created. I'm going to click on OK, and that policy is getting called from an already existing ACL. So let me go to, let me back up once. Let me click on cancel. We go to custom options and then access lists. Okay, so the ACLs are already here. Like I said, I did test this out beforehand. I'm going to go ahead and I'm actually going to delete these ACLs just so that they're no longer here. We're going to create these again so you guys can see what they look like. Go ahead and delete that as well. Click on OK. Then go back to the lists, and on data prefix, I'm going to go ahead and delete this guy right here. So router 15. So now he's gone. So if you've already got something you've matched on and then you need another one, well, that's actually really easy. Just click on new data prefix. The name of it's going to be iOS underscore or iOS 15 underscore loopback. Then come in here and do the IP address you're wanting to match on. So 15.15.15/32. Click on add, and then we're going to go to localized policy. I'm going to go ahead and add a policy, and we can see that in the data prefix that these are created. So I'm going to go ahead and click on next, and then the next option here we have is going to be for QoS. We're not there yet. We'll take a look at that at a future video. The next one we're going to click next because we don't want to create an access list or a QoS policy. We are going to create a few access lists. So we're going to create an access control list policy. I'm going to add one here. The name of this guy, and they have to be individual ACLs. You can't create one ACL and call the logic multiple times. You could, probably. I have not tested it out this way because it doesn't make sense to do it this way. So if you want to, feel free and try that out, create in multiple sequence numbers and go that route, be my guest. So what I'm going to do is call this iOS 13 underscore loopback, and I'm going to copy and paste that in there. I'm going to create a new sequence, and then sequence rule, and the match portion, I'm going to say the destination data prefix, the source destination prefix, because this is going to be traffic that's being received inbound. I'm going to call iOS 13 loopback, and then on the actions, I'm going to set it to drop, but I'm also going to add a counter and call this iOS 13 counter. Something simple like that. Click on Save ACL. Or, I always made this mistake. Let me scoot this up just a little bit higher, minimize this a little bit, and bring this down just a touch, just so it's right there. Click on Save, Match, and Continue, and then Save ACL Policy. I'm going to go ahead and create another one, so add another IPv4 ACL policy. This one here is going to be iOS 15 loopback. Copy and paste that in, and then create a sequence number, or add ACL sequence, then sequence rule. I'm going to say source data prefix. I'm going to choose iOS 15 loopback. I'm going to set the action to be drop and the counter to be iOS 15 underscore counter. Okay, so I actually have to go back and edit the other ACL real quick. But what I have to do is this save this one here, but I have to go underneath the default action and change the default action to be permit, or accept. and save, match, and continue. Because if I don't do that, I'm going to be dropping all the traffic, right? So if I don't, I've got a specific entry in there that says block traffic coming from this specific IP address. If I don't change the default action to be accept, it's going to be dropping everything. So I'm going to save ACL policy. I'm going to come back over here to this guy and edit. Then click on default action, and then little pencil, and then change that to be accept. Save, match, and continue, and boom, save ACL policy. Okay, I'm going to create one more. This one's going to take a little bit longer to build. I'm going to come in here and just type in block underscore telnet. Let's just say block underscore telnet. Copy and paste that in. And then add ACL sequence, add a sequence rule. Now, I'm not going to match on a IP address or subnet. I'm going to basically just say, I don't really care where the traffic is coming from or going to. I just want to block telnet. So it's more of a, it isn't as it's specificity here, or which one's more specific versus less specific. It's this is more of an extended ACL. So we're focusing on the protocol and the port versus just the subnet that a standard ACL is going to match on. So this will be your extended ACL variation. So I'm going to say the protocol here. In this case here, TCP is protocol 6. And the destination port is going to be 23. Okay? It's going to be set to action and set to drop. And I'm also going to set up a counter to be telnet counter. Save, match, and actions. And then underneath default action, change that to be accept and save, match, and continue, and actions. Click save ACL policy. So now I have block. I have iOS 13's loopback, iOS 15's loopback, and then block telnet. I'm going to click on next. I'm going to bypass the route policy, but I am going to create an ACL policy. So I'm going to call this the single site ACL policy, and copy and paste that there. And then I can click on preview, and this is what it's going to look like. Down here I have my list that call the loopback addresses of iOS 13 and 15. Those particular data prefixes are being called, and then they're dropping the traffic if a source IP address matches those IPs, and then the default action is allow anything else. Same thing here. I have another access list called block telnet, where in sequence 1 we're matching on protocol 6 with the destination port of port 23. And we're going to drop that, and we're going to say, I want you to count anytime there's a drop, but in the default action we're going to go ahead and allow it. I'm going to click Save Policy. And now that policy has been created. Now I need to go to the next step, and I need to actually go to the template, the device template specifically, and I need to push this policy down to BH3 and 4. Let's go ahead and do that real quick. So come over here to Templates. On Device Template, we're going to choose Single Device Template and say Edit. Underneath here, we're going to click on Additional Templates. And then from policy, we're going to call the single site ACL policy, and then we're going to click on update. We don't actually have to do a whole lot right now because we're not trying to affect individual operations at the vEdge level. We're just trying to get the policy there. Because if we were to pull up vEdge 3 or 4, for example, and let's log in real quick and do a show run policy, I had no policies created. Right, so nothing's there. We're going to come over here and click on Next, and then Configure Devices. I'm going to push the config down because we already looked at the config preview, so we know what's going to get pushed. And I'm going to pause the video. All right, the config was pushed, so we're going to hit the up arrow, and now we can see that the policy was pushed. Okay, but just to keep you guys, just keep everything in mind, nothing's been applied yet. We've literally just taken the logic from vManage and pushed it down to the vEdges. That's all we've done so far. So now we need to go and actually enforce it. So we're going to go back to the templates, underneath the feature template, and then I'm going to select the individual templates themselves. So we're going to go grab VPN1 for the gigabit interface, which should be this guy right here. Let's scoot this out just a little bit more. We have VPN1 interface G0/2, which is what we want. We're going to come over here, click on Edit, and I'm going to come underneath here ACL and QoS. So what other things I'm going to go do is I'm actually going to have this guy sitting right here, and I'm going to scoot this guy up so I have all the ACL names literally right there in front of me. So all I have to do is click back and forth, because if you don't have them readily available, because there's no way for you to look them up, right? You can't. There's no drop-down box, unfortunately. Hopefully that's an update and a release down the road, but right now it's not there. So from here, I'm going to click on Global and turn it on, and the ACL is going to be device specific. So I'm going to do that. Now I could, for the ingress ACL, because we have two different ACLs, I'm going to say device specific, because I don't need to apply both iOS 13 and iOS 15 to the same device, right? So I'm going to say device specific on this one. But for the egress ACL, I'm going to go to Global, click on, and then I'm going to choose the actual ACL, which is right here, which is going to be block telnet. I'm going to paste that right there. It's going to be global because this is going to affect both devices. I'm going to go ahead and click on update, and then that's going to cause me to go to update the actual, oh, I grabbed the wrong, I just noticed that I grabbed the wrong vEdge. So let me go back to templates real quick and to feature template. So that's my fault. Was not paying attention to what template I was grabbing. We need to go into single site for gig 0/2. Let me scoot this out just a little bit so we can see it all. See, that's what ended up happening. It jumped on me. So single site, this guy right here, go all the way across, make sure it's the same one, and then edit. And then again, ACL, QoS, come down here to ingress ACL, global, turn it on, and then for the actual ACL, it's going to be device specific. But for the egress ACL, I'm going to turn it global to turn it on, and I'm just going to go ahead and plug in the block telnet ACL. I'm going to go ahead and click on update. Now that what will end up happening is I'll have to go in and specify which specific ACL I want to match on. I'm going to come down here, and then the ACL name is going to be right here. So for vEdge 3, this is going to be iOS 13. Click on update, and then for this guy over here, let's scoot all the way to the right. For the access list, should be at the very bottom. Not quite. Where is it? Let me just click on here. Make it easier on myself. Come down to the bottom for access list, and then grab iOS 15 loopback. Plug that in there, and click on update. Now what's going to happen is I'm going to click on next, and it's going to go ahead and push that config. I'm going to go ahead and say configure devices, click on OK, and then I will pause the video and wait for that to actually take effect. Alright, so the apply was successful, so let's go ahead and actually take a look at this from the command line. We're going to look at, say, router 13 or vEdge 3 first. So I'm going to come in here and do a show run VPN1 interface GE0/2, and we should see two ACLs applied. We should see iOS 13 inbound, and we should see the access list of block telnet outbound. Okay, so now let's go over to router 13 and do a little bit of testing here. So what I'm going to do is I'm going to ping, in this case here, show IP route. I don't believe I have a default at the moment, and I don't. So what I need to go do real quick is on vEdge 1, let me do I turned off the advertisement of OSPF. So let me let me do that real quick just so we have a default route, because I do not have NAT operational yet. So VPN1, OMP, advertise, OSPF, external. Commit that, and then go back over here to vEdge. Go back over here to the router, hit the up arrow, and now we have a default route. So now I'm going to ping 1.2.3.4, and I should be able to reach the loopback address of the internet, which I can. Now if I hit the up arrow and go source loopback 0, that is denied, okay, which is what we want to see. And from router 15, same thing here. I'm going to go ahead and I'm going to ping 1.2.3.4. That should be allowed, no problem. But if I source that from loopback 0, show IP interface brief, so config t interface loopback 0, IP address of 15.15.15.15/32, and there. So it's not available. Exactly what I'm looking for. Now, if I go back to vEdge 3 and I do a show policy access list counters, we should see that that is taking effect, which it is, right? We block traffic from iOS 13 coming inbound. If I go to vEdge4, let me log into him real quick. And we're going to do a show policy, access list counters. Same thing there. We're matching on router 15 coming inbound. So it's working the way that we want it to. Now, here is the trigger. We're going to go over to router 5. And I'm going to go ahead and I'm going to telnet to 10.3.13.13. And I'm trying to telnet to that. If I look at vEdge3 and hit the up arrow, now we're getting matches on this access list. It's trying to connect via telnet, but it's not able to. Now, if I was to disable that, obviously those ACLs, and you can disable them on a per directionality basis, so you can turn the one off for ingress or turn one off for egress, whatever the case might be. But as you can see, it is not working, which is what the desired result is. But if I went to iOS 5 and I did a telnet to, let me make sure that 13's actually got the web connection up and running. So IP HTTP server, IP HTTP authentication is local. Do show run pipe and include username. Just make sure that's there before I try to do it. And it fails. Give that a second to okay, it's there. So now I'm going to go back to router 5. I'm going to telnet to 10.3.13.13, but via port 80. And that opens up all day long. If I go over to router 13 and I do a show IP HTTP server connections, blammo, I have an active connection from 10.5.6.181 right there. So we know we have an active inbound connection. So that just goes to show you that we do have the configuration up and running correctly via the ACLs. So as you can see, if you wanted to go in more detail, you could. When we get to the QoS portion and we start diving into that, we'll be a little bit more specific in our what we're doing. Instead of blocking traffic, we'll say match on, say, DSCP or set this particular Q value or something along those lines. So, but for right now, that's basically how you would do that. Until next time, guys, thank you so much for stopping by and hanging out with me. I'll catch all of you in the next video.